Welcome to the fourth module, first session. My dear friends, we have discussed the energy, non-conventional energy sources in the first module, and in the second module, we have also discussed the refrigeration and air conditioning. This is the four. In the third module, we have also discussed uh, the energy sources, that is from the IC engines. Okay. Now, in the fourth module, we will talk about the materials. So, before I just proceed with the module, let me go through the syllabus. So, in the fourth module, we will be talking about the properties, composition, and industrial applications of emerging materials. Along with the conventional materials, we will also study the advanced materials. Now, here in this chapter of the fourth module, we will talk about metals. We will talk about the ferrous type of metals, for example, cast iron, tool steels, and stainless steels. And in the non-ferrous metals, we will talk about aluminum, brass, and the bronze. And then we will also study about the polymers, that is nothing but the thermoplastics and thermosetting polymers. Then we will also study about the ceramics, glass, optical fiber glass, ceramics, and then we will study composites, fiber reinforced composites, metal matrix composites, and then the smart materials like piezoelectric materials, shape memory alloys, and then semiconductors and insulators. Then in the second chapter, actually, we will be talking about much on to this joining processes, in which there are three different types of joining processes apart from the rivets I'm just talking about. It's a soldering, brazing, and welding. We will study what is this soldering, what is this brazing, and welding basically, and then we will also study the classification and methods of soldering, brazing, and welding, and brief description of arc welding, oxyacetylene welding, TIG welding, and then we will also study the MIG welding also, that is tungsten inert gas welding, and MIG stands for metal inert gas welding. And then we will also study the belt drives, in which we will study what are these drives, what are the importance of these belt drives, and we will also study what is this open belt drives and crossed belt drives. We will study the definition of the terminology which are related to the belt drives, like slip, creep, velocity ratios, and then derivations of the length of the belt in the open and cross belt drives. And then we will also study the ratio of tension in flat belt drives, and we will also study the advantages and disadvantages of using V belt instead of the flat belts, and we will also study the advantages and disadvantages of timing belts, and one or two numerical simple problems, because it is only the ratios of the velocity and then the length of the belt derivations will be there. So the easy problems will be simple problems, we shall sort it out. And in the final chapter of this fourth module, we shall discuss about the gear drives. What are these gears? What are these gear drives types, like spur gear, helical gear, bevel gear, worm gear, and rack and pinion gears. And corresponding to this gear drives, we will also study the velocity ratio, advantages and disadvantages of belt gear drives over the belt drives, and simple numerical problems on the same velocity ratio. Okay, let us talk about the properties. Materials are various kinds which are developed, and it is difficult to describe all of them in a single text. To be frank, there are Many materials are there, we cannot just discuss over. So what we will do it is we just broadly classify that, and the one materials which have been used popularly will be concentrated over here. Here it is confined to the study of those materials which are commonly used for various engineering applications. Only most, of course, all the materials have been used in engineering applications, but one which have been very popular in the applications which will study those particular materials. These materials have also set a properties which are used for specific applications, selections of materials for specific project or applications is an important activity for success and failure of that project. Any materials starting from whether it may be mobile or a laptop or a system, or it may be a bike or a car or a aeroplane, whatever may be the project it might be, anything which is being made up of some materials will definitely depends upon the properties of these materials, and that their the particular material, specific material applications, and they it's a success. A metals a material that is typically hard, opaque, shiny, and features good electrical and thermal conductivity. That is what we call it as a metal. These metals are generally malleable. They can be hammered and are pressed permanently out of shape without breaking or cracking, well as fusible and ductile materials can be either ferrous or maybe a non-ferrous metals. Okay, without altering the shapes, we can make them into a perfect shape in which we are just looking out to. Okay, basically these ferrous metals can be classified into ferrous metals as well as the non-ferrous metals. These ferrous metals contain iron as their major composition, while the non-ferrous metals do not have. Both ferrous and non-ferrous are divided into pure metals and alloys, whereas non-ferrous metals will not have iron as their iron presence will be there, but not as a major constituent. When we talk about the composition, say take for example, if you take a cast iron, 96 to 98% of that majority composition will be iron, whereas non-ferrous metal, if you take aluminum, the Fe percentage, that is iron percentage, will be less than 1 or 2. So that means the predominant composition of the particular material will be an iron in case of ferrous metals, and in case of non-ferrous metals it will be other than the iron. Then we call it as a non-ferrous metals. Now altogether mixing this ferrous and non-ferrous metals, we classify them into pure metals and alloys. A pure metal is an element, example iron, or a copper, or a gold, unalloyed. That means they are they have been a major constituent materials, and no mixing of material, other mixing of materials will be there with the other substance. Whereas an alloy is a mixture of two or more elements. Say for example, I will mix with iron and carbon to make another material with a particularly importance. Say for example steel, and we mix with the variable composition of the carbon in order to get different grades of steels also, that is low carbon steel, medium carbon steel, and high carbon steel. And we also have one of the most popular steel, that is what, the stainless steel. Is it clear? How we classify this materials? The first module deals with the classification of the engineering materials and their processing techniques. The engineering materials can broadly be classified as the ferrous metals, non-ferrous metals, that is aluminum, magnesium, copper, nickel, titanium, etc. And then we also have a plastics, thermoplastics and thermosetting plastics. Then we have ceramics and diamond, and then we have a composite materials, and then the nanomaterials. The last two one are the most advanced materials into the materials engineering, though they have been derived from the basic metals only. In order, because the industrial requirements keeps varying, Now, say for example, my dear friends, if you see a bus which have been made up of steel or aluminum, or it is with the stainless steel sheets, correct? The same steel, if I use it for aeroplane, it will not fly up at all. So that means we need more lightweight materials which are required for the aeroplanes. Then we will look out for the nanomaterials or maybe the composite materials. So broadly, the materials have been classified in this fashion. Now let me go one by one. The ferrous metals. In the ferrous metals, the first pig iron is a one. Why we call it as a pig iron? It is only because it is interesting. When we see in the foundries where the material have been extracted or in the metallurgical industries, when we pour a liquid metal, when we pour a liquid metal, we will get a ore, we will heat it, and we will remove the slag, and then whatever the liquid material, that is the iron, will be there. When we pour it, the molds were looking like a pig shape, that is a pig face. It was similar like to the pig face. So that is the reason why we just call it as a pig iron. No need to worry. Okay, it's an intermediate product of a smelting iron. Smelting means we just take the iron ore and we will melt it. Okay, whatever the iron that we are getting, which is a raw iron, that is what is nothing but a smelting of iron ore with a high carbon fuel such as a coke, usually with the limestone as a flux. We will take the smelting iron ore with a high carbon fuel, high carbon content which is there in the fuel, that is like a coke. It will have a high carbon fuel. We will use the limestone as a flux which accelerates the reaction. It is a molten iron from the blast furnace. A furnace is a place where ore will be melted to a very high temperature so that we can extract the metal which is being present in that. Okay. Then which is a large and cylindrical shaped furnaces charged with iron ore, coke and limestone. Charcoal and anthracite have also been used as a fuel. Next one is a wrought iron. Wrought iron Wrought iron is an iron alloy with a very low carbon, whereas here in the pig iron, among all iron, the pig iron has got the maximum content of the carbon. Okay, it's an alloy. Wrought iron is an alloy with a very low carbon, which has been less than 0.08% of the carbon content, in contrast to the cast iron, where the cast iron will have 2.1% to 4% and has a fibrous inclusions known as a slag up to 2% by the weight. It is a semi-fused mass of iron with slag inclusions, which gives it in a grain resembling wood that is visible when it is etched or bent to the point of failure. Basically, this cast iron, once again, the cast iron has got a composition alloy of iron and 2.5, that is 2.1 to 4% of carbon present will be there, with a silicon percentage of 1.1% to the 3%, and the traces of magnesium, sulfur and phosphorus will be present in this cast iron. Cast iron is an iron or a ferrous alloy which has been heated until it liquefies and is then poured into the molds to solidify. It is usually made up of a pig iron, from the pig iron. So this cast iron and wrought iron have been extracted with the use of a pig iron mixture. It is usually made from pig iron. The alloy constituents affect its color when fractured. White cast iron has carbide impurities which allow cracks to pass straight through. Now the next one is a grey cast iron, or just a grey iron, or a grey cast iron. It is also is a type of cast iron that has a graphitic microstructure. It is named after the grey color of the fracture it forms. Since after the fracture it appears to be in a grey color, so it has been called as a gray iron or a gray cast iron. Okay, which is due to the presence of graphite. It is the most common cast iron and the most widely used cast material based on a weight. Applications, when it comes to the applications, automotive engine blocks, gears, flywheels, frames, white cast iron displays white fractured surfaces due to the presence of cementite, or actually it is some compositions, it's a one phase of the liquid iron after forming it to a solid rock. So one stage. Okay. Composition, it will have 1.8 to 3.6% of carbon and 0.5 to 2% of silicon along with sulfur. Application, it is used in car wheels. The car wheels, or that is alloy wheels, what we say, that completely thing will be made up of car wheels because it is absorbs a lot of vibrations and it can take more load. And sprockets, rolling mills and rolls. Okay. The next one is there are only the materials, actually it's with the same different materials. Only thing is we are just about how they have been formed. So I quickly go through it. The malleable iron starts as a white iron casting that is then heat treated at about 900 degrees centigrade, that is 1650 degree Fahrenheit. Graphite separates out much more much more slowly in this case, so that the tension has time to form it into spheroidal particles rather than flakes. Composition, 2 to 3% of carbon will be there, and silicon percentage is around 0.6 to 1.3 percentage along with the sulfur. Applications are something like this, which are being used in universal joints, yokes, differential gears, compressors, crankshafts, and flanges. Mild steel, which has been used, mild steel has got a composition of alloy of iron and it has a carbon percentage of 0.15 to 0.3%. That means the carbon percentage is less. Properties and characteristics are very tough and it is ductile in nature and malleable. Good tensile strength, few resistance to corrosion. General purpose engineering materials have been, it is say for example the desk, chairs, carts, everything will be made up of this mild steel. Steel are the alloys of iron and carbon widely used in construction and other applications because of their high tensile strength and low costs. Carbon, other elements and inclusions within iron act as hardening agents that prevent the movement of dislocations that otherwise occurs in the crystal lattices of iron atoms. The carbon in typical steel alloy may be contributed up to 2.1 percentage of its weight, varying the amount of alloying elements. Their formation of steels either as a solute elements or as precipitated phases retards the movement of those dislocations that make iron so ductile and weak, or thus controls the qualities such as hardness, ductility, and tensile strength of a resulting steel. Steel's strength compared to the pure iron is only possible at an expense of ductility, of which iron has an excess. So, based on the composition of the alloying element, the properties of the steel also varies. Now, my dear friends, even if you can observe, nowadays without the paint, the stainless steels can be used and it doesn't get rust. Though it is a ferrous metals, it doesn't get rust. Even the utensils that we use it at home are also made up of stainless steel, isn't it? So let us talk about non types of non-ferrous metals. Aluminum is one of the most popular material that has been used in the non-ferrous metals category. Or this is also called as aluminium or aluminum. Okay. Now see, is a chemical element in the boron group, in the boron group with a symbol of aluminum Al, and atomic number is 13. Okay, it is whereas for the iron it is 21. It is a silvery white, soft, non-magnetic. It's a non almost all the non-ferrous metals are non-magnetic. Okay, aluminum is the third most abundant element after oxygen and silicon, and the most abundant metal in the Earth's crust also. It makes up about 8% by weight of the Earth's solid surface. So that is wonderful. 8% is a very huge percentage actually. Composition, it's a pure aluminum as an element. Properties and characteristics. No, even in aluminum also we have alloys. For example, aluminum 6061, aluminum 8081, 8085, 6063, all the different types of aluminum alloys are all there. But we are just talking about the base as an element aluminum. It's a good strength to weight ratio. It's very light in weight, soft, it's ductile, good conductor of heat and electricity. Application for the kitchen equipments, even our pressure cookers, which are all made up of aluminum. Window frames, general cast components, all comes under the category of which have been made up of aluminum. Copper is a chemical element with the symbol Cu, which is from the Latin word cuprum. Okay, and atomic number is 29. It is a ductile metal with a very high thermal and electrical conductivity. The pure copper is soft and malleable. A freshly exposed surface has a reddish orange in color. It is used as a conductor of heat and electricity. It is a tremendous amount of heat and electricity it will allow conductor. A building material and a constituent of various metal alloys have been made up of this. Composition, it is a pure aluminum. Properties and characteristics, that is a malleable and ductile in nature with a good conductor of heat and electricity, resistant to corrosion. Application, water pipes which have been made, electrical wires majorly. This copper is extensively used for electrical wires and decorative goods, and even the cable wires also, which have been made up of the copper. And then the zinc. Zinc is a commercially also called as a spelter. Is a chemical element with a symbol of Zn, and atomic number is 30. It is the first element of group 12 of the periodic table. In some respects, zinc is a chemically similar to the magnesium, Mg actually, similar to the magnesium. Its iron is a similar size, and its only common oxidation state is +2. Zinc is the 24th most abundant element in the Earth's crust and have 5 stable isotopes. Different types of zinc elements, where the aluminum is the 8th most, whereas the zinc is the 24th most. Composition, pure zinc, it will have it. It is a weak metal, extremely resistant to corrosion. So, extremely resistant to corrosion. That is the most reason why this zinc coatings are also been made. Zinc coatings, paint, something like a paint, even the zinc coatings have been made in order to make a corrosion proof or a corrosion resistant materials. Usually used for coating steel, that is what I was just talking, to make galvanized items. Okay. Now next, brass is an alloy made up of copper and zinc. Copper and zinc are been mixed and they have been making this brass element. The proportion of zinc and copper can be varied to create a range of brass elements with varying properties. It is substitution. Atoms of two constituents may replace each other within the same crystal structure. Alloy of copper and zinc properties and characteristics are like resistant to corrosion, fairly hard, good. That means it's not too hard and it is not too soft also. That is what it means. Fairly hard, good conductor of heat and electricity. This brass cast items such as water taps and then ornaments, and it is also used most probably in the idols, in the preparation of idols. Apart from the bronze, bronze is one mostly used in decorative applications. Okay, now this bronze is an alloy consisting of primarily of copper and the addition of other metals, usually tin and sometimes arsenic, phosphorus and aluminum, magnesium, and then silicon will be added. Okay, these additions produces an alloy much harder than a copper alloy alone. Okay, the historical period where the archaeological record contains many bronze artifacts, which is known as the Bronze Age. Bronze Age, it is called as a Bronze Age because alloy of copper and tin will be there, which possess a fairly strongness. It's highly malleable and then ductile when soft. Okay, it's extensively used in archaeological, architectural fittings and decorative goods. Right? Let us talk about one of the most important and maybe not the in your syllabus the last non-ferrous metals. It is nothing but a tin. Tin is, though its spelling is tin, it has been called with a chemical element of Sn. It is only because of the Latin, in Latin tin is been identified as tannum, Stannum. So this has been spelled as Sn as a chemical element and atomic number of 50. It is a main group metal of protein of the periodic table. Tin shows a chemical similarity to both neighboring group protein elements, germanium and lead, and has two possible oxidation states, +2 and slightly more stable in +4 elements. Basically, it contains pure tin. It is soft, weak, and malleable and highly ductile. Whenever I say it is soft, it will be ductile and resistant to corrosion. Usually, these are used as a mixing elements with a coating of steels to form tin plates. Okay. Now, let us talk about the composite materials. A composite material or a composite is nothing but a combination of two materials. Alloys are different, where we will mix it up in a microscopic level, whereas the composite materials, we are just mixing up two materials in a macroscopic level and are not soluble in each other in which one of the materials. So that is what we call it as a composite material. Say for example, if you take a the brass element, whereas here the brass element is an alloy of copper and zinc, which are mixable. Whereas when we talk about composite materials which are not mixable with each other, called as a reinforcing phase, is in the form of fibers or it may be in a sheets or it may be a particles also, and is embedded in the other materials called as a matrix. Is that clear? It is something like we have a milk which is a major material. We will mix the coffee powder, we will mix the tea powder, or we will mix the sugar. So what happens? The milk, by adding the reinforcement material, it has given a different material. So same way, the milk was there, we have mixed tea powder, so it has become a tea. Its property and taste has been changed. So whenever we do that, we call the milk as a matrix phase and tea powder as a reinforcement material. So the same thing we will do it in materials also. We will have a matrix phase and then we will mix up with the other phase materials. The reinforcing material and the matrix material can be a metal or it may be a ceramic or it may be polymer, and need not necessary that they should mix up thoroughly with that. Need not necessary. Tea powder will not get mixes up completely, but only the essence will be there and we will replace it, right? So similarly, in a composite materials, it is no rules. There is no hard bind rules that the both particles have to mix each other. It will not. Okay. Composite materials have a fiber or a particle phase that is a stiffer and stronger than the continuous matrix phase and serves as the principal load carrying members. Is it clear? Now, these composite materials can be broadly classified into two ways. One is a base material matrix and the other one is a according to the shape of reinforcement. According to the base materials, we will classify that into polymer composites, ceramic composites and metal matrix composites. Whereas according to the shape of reinforcement, we classify that into fiber composites, laminate composites and particulate composites. This is how we just classify the composite materials. In the next class, we shall talk about these polymer composites, ceramic composites and different types of composite materials and their applications and uses.